Good day. This is Basic Calculus, topic continuity. Next, let's have continuity of a function on an interval. So let's review first the interval notation. So we write the beginning and ending numbers of an interval and use a square bracket when we want to include the extreme values, or a round bracket or parenthesis when we don't want to include the extreme values. So for example, in A here, we have here the closed interval from -1 to 1, which means -1 and 1 are included. And since we used square brackets, then this is a closed interval. For letter B, we have here an open interval because we have used round brackets. So we have the open interval from -2 to 0, which means -2 and 0 are not included. Okay? Because again, this is an open interval. And for letter C, we can have a combination. So we have here a square bracket. So it's the interval from 0 to 4, including 0, but not including 4. Okay? So 0 is included, but 4 is not included. So that's the review for interval notation. Now let's go to example 7. Consider the graph of the function given below. So this is the graph of f of x equals 3x minus 1. So using the graph, determine if the function is continuous on the following intervals. So first, we have here from -1 to 1, including -1 and 1 because this is a closed interval. So all we need to do is to locate where is -1 because this is the starting point of our interval. So from -1, okay, this is x-axis, and then -1 on the graph, it's here. And then let's trace it going to x equals 1. Okay, so stopping here. So there's no hole, there's no break on x equals -1 on the interval from -1 to +1. So meaning to say, for letter A, our answer will be continuous. Alright, next, let's go to letter B. So for letter B, from -infinity to 0. Since from -infinity, we can start from any large negative number or negative integer. So let's start here and then tracing it going to 0. So 0 is not included, and as we trace, there's no hole, there's no break, there's no jump, there's no vertical asymptote. So on that interval, the function is continuous. Okay? And lastly, for letter C, from 0 to +infinity. So from 0, x equals 0, going to +infinity. Okay, we can just trace it upwards. So it's continuous. Alright, so looking at our function here, what we have is a linear function. And looking at our graph, there's no hole, there's no jump, there's no vertical asymptote. So we can safely say, and since 3x minus 1 is a polynomial function, we can safely say that all polynomial functions are continuous for all real numbers. That means at any point or on any interval, polynomial functions are always continuous. Next, let's have this one, example 8. Now here, our given is a rational function, and this is the graph of our rational function, in which clearly we can see that at x equals 1, there is a hole on the graph. Alright, so we must be careful. Now, letter A, okay, from the interval, okay, not including -1, but including +1. Alright, since +1 is included, meaning to say the hole, this hole in this part is included in the interval. And since we have encountered a hole on the interval from -1, not including -1, going to +1, including +1, then the graph is not continuous on the specific interval. Alright? Now next, let's have from -infinity going to 0. So from -infinity going to 0, from -infinity going to 0, there's no hole, there's no break, there's no jump, there's no vertical asymptote. So meaning to say the graph is continuous on that specific interval. Next, for the third one, for letter C, at 0 going to +infinity. So from 0 here, going to +infinity, we encountered a hole at x equals 1. Again, from 0 going to +infinity, we encountered a hole at x equals +1. So meaning to say, on that specific interval, the function is not continuous. Alright? So what makes a function continuous for all real number? So again, first, we need to check at any point on the graph if there is a hole at any point, meaning to say the function is not continuous for all real number. Same thing, if there's a jump at any point on the graph, then the function is not continuous for all real number. And if there is a vertical asymptote, still the same, the function is not continuous for all real numbers. So here we have f of x and g of x. Let's try to see which among the two functions is continuous at all real numbers. Again, which of the two functions, f of x and g of x, is continuous for all real numbers? Alright, correct. It's f of x. Okay, because inspecting f of x, tracing it from left to right, we did not encounter a hole, a jump, or a vertical asymptote. So f of x is continuous for all real numbers. But for g of x, tracing g of x, alright, we have encountered a hole at x equals 0. So this hole makes g of x not continuous for all real numbers. Okay? So math tip, if you can evaluate any limit of the function using only the substitution method, then the function is continuous. So as I said earlier in this video, when you deal with polynomial functions, then and you can solve for its limit using the substitution method, then the function is continuous for all real numbers. Meaning to say, polynomial functions are continuous at any point or at any number, and is also continuous on any interval. So that's all for today. I hope you have learned something. See you in our next video.